May 1945. Friedrichshafen, Germany. Dr. Heinrich Müller stood in the ruins of what had been Germany's finest aircraft engine manufacturing facility. The walls were scarred by bomb damage, the roof partially collapsed, but the real devastation wasn't physical. It was intellectual. The Americans had set up a technical exhibition in the captured factory, and German engineers were being invited to tour it. Not as colleagues, as defeated enemies being given a lesson in why they'd lost. Heinrich had spent 15 years designing aircraft engines for the Luftwaffe. He'd helped develop the Daimler-Benz DB605 that powered the Messerschmitt Bf 109. He'd been told Germany possessed the most advanced manufacturing capability in the world, that German engineering precision was unmatched, that the Americans were crude industrialists who couldn't compete with German technical excellence. He was about to learn that everything was a lie. The invitation had come through American technical intelligence officers 3 days earlier. All German engineers and factory managers in the region were to attend a demonstration of American manufacturing equipment captured from retreating Wehrmacht forces who'd seized it from American facilities in France. The irony wasn't lost on Heinrich. German forces had captured American equipment, tried to reverse engineer it, failed to understand how it worked, and now the Americans were explaining it to them like teachers instructing slow students. Major Robert Crawford, a manufacturing engineer from Detroit who'd enlisted after Pearl Harbor, stood at the entrance to the exhibition hall with a translator. "Welcome, gentlemen. What you're about to see represents standard American mass production equipment. Nothing experimental, nothing secret, just the tools we use every day in factories across the United States." Heinrich entered with a group of other German engineers, their faces showing the exhaustion of defeat mixed with the bitter curiosity of men who needed to understand how they'd been beaten. The first station contained a machine tool, a massive automated drilling and boring machine manufactured by Cincinnati Milling Machine Company. It sat on reinforced concrete blocks, painted industrial gray, unremarkable except for its size. Crawford gestured to it. "This is a standard production milling machine, used in virtually every American factory producing aircraft, vehicles, or weapons. Automated feed mechanisms, interchangeable tooling, designed for operation by semi-skilled workers after minimal training." One of the German engineers, a man named Weber who'd worked at Messerschmitt, stepped forward. "How many of these does America have?" Crawford consulted a clipboard. In 1944, American factories operated approximately 55,000 machines of this type or similar capability. Heinrich felt something cold settle in his stomach. 55,000. Germany's entire machine tool inventory across all factories, for all purposes, was perhaps 8,000 machines, and most of those were pre-war models showing their age. Weber wasn't finished. And production rate? How many per month does this machine complete? Crawford smiled, but there was no warmth in it. This particular model can complete approximately 200 engine blocks per month when operated continuously. The German engineers exchanged glances. 200 engine blocks per month from one machine. The entire Daimler-Benz facility that Heinrich had worked in produced perhaps 600 engines per month total, using dozens of skilled machinists and hundreds of man-hours per engine. Crawford continued, oblivious to or perhaps enjoying the shock on the German faces. "This machine runs 24 hours per day in 3 8-hour shifts. Operators require approximately 2 weeks of training. Maintenance is performed by specialists, but the actual operation can be done by anyone who can read gauges and follow procedures." Heinrich thought about the skilled machinists at Daimler-Benz. Men who'd spent years learning their craft, who could measure tolerances to within hundredths of a millimeter by feel, who understood metal working with an intuition born from decades of experience. And the Americans were replacing them with machines operated by workers trained in 2 weeks. Weber asked the question they were all thinking. What is the production capacity of one American aircraft engine factory? Crawford checked his notes again. The Ford Willow Run plant produces approximately 650 B-24 Liberator bombers per month at peak capacity. Each bomber requires 4 engines, so that's 2,600 engines per month from a single facility. The number was incomprehensible. Germany's entire aircraft engine production across all manufacturers, all factories, all types, had peaked at perhaps 4,000 engines per month in 1944. One American factory was producing 2/3 of Germany's total output. Another German engineer, a younger man named Dieter who'd worked on jet engine development, spoke up. But surely quality suffers? American equipment is known for being crude, mass-produced without German precision. Crawford's expression hardened. That's what you were told, yes. Let me show you something. He walked to a table where several engine components were laid out. These are cylinder heads from a Wright R-1820 radial engine, removed from a damaged B-17. They've been through approximately 400 hours of operation. He handed one to Heinrich. Measure it. Check the tolerances. Heinrich pulled a micrometer from his pocket. Every engineer carried one. It was as natural as carrying a wallet. He measured the cylinder bore, the valve seats, the mounting surfaces. The precision was extraordinary. Tolerances within 0.001 inches even after 400 hours of operation. The metal showed wear, but even wear, consistent across all surfaces. This was not crude manufacturing. This was precision engineering executed at mass production scale. How? Heinrich asked, the word escaping before he could stop it. How do you achieve this precision with automated machinery? Crawford gestured back to the milling machine. Design for manufacturing. Every part is engineered from the beginning to be produced by machines. We don't design a part and then figure out how to make it. We design the part so it can be made efficiently. Interchangeable components. Any cylinder head fits any engine of the same model. Any piston fits any cylinder. Any connecting rod fits any crankshaft. No hand fitting. No individual adjustment. Heinrich understood the implications immediately. German manufacturing still relied on skilled craftsmen to hand-fit components. Each engine was slightly different. Parts from one engine wouldn't necessarily fit another without modification. It meant German engines were works of art, individually crafted masterpieces. American engines were identical products stamped out by machines. And in war, identical products stamped out by machines won. The second station featured something even more disturbing. An assembly line conveyor system with automated positioning stations. Crawford explained with the patient tone of a professor teaching basic concepts. This is a standard Ford Motor Company assembly line section, captured by Wehrmacht forces in 1944 from a Ford facility in France, though they never figured out how to use it properly. The conveyor moved at a fixed speed, approximately 2 feet per minute. Along its length, workstations were positioned at precise intervals. Each station had tools mounted on balanced arms, parts bins positioned within easy reach, and visual guides showing exactly where each component should be placed. The genius, Crawford explained, is not in any individual element. It's in the system. Each worker performs one specific task, the same task, repeatedly. The conveyor brings the work to them. They never move their feet. Everything they need is within arm's reach. We've timed it. A trained worker can complete their station task in exactly 47 seconds. The conveyor moves the work to the next station every 48 seconds, allowing 1 second margin. Dieter stared at the setup. This is manufacturing humans like machines. Crawford nodded. Yes. And it's more efficient than any craftsman-based system ever invented. Let me give you numbers. A skilled German mechanic might assemble one complete aircraft engine in perhaps 80 hours, working with hand tools and individual parts. This system? 27 minutes from raw castings to completed engine. The German engineers were silent. 27 minutes. It was impossible. It was also clearly true. The evidence was standing in front of them. Weber spoke quietly. How many of these assembly lines does America operate? Crawford consulted his ever-present clipboard. As of 1944, approximately 800 major assembly lines producing aircraft, engines, vehicles, weapons, and components. Smaller operations number in the thousands. Heinrich did the mathematics in his head. If each line produced even a fraction of what Crawford described, the total output was staggering. Germany had been trying to fight an industrial superpower with craftsman workshops. The third station displayed something that hurt even more. Tool and die sets, Crawford picked up a stamping die, a massive steel form used to shape sheet metal. This die produces P-51 Mustang wing ribs, can stamp one rib every 6 seconds. The die is good for approximately 50,000 stampings before requiring refurbishment. One of the older German engineers, a man named Hoffmann who'd worked in manufacturing since before the war, examined the die closely. The precision of this tool is remarkable. The steel quality must be extraordinary to withstand such repeated use. Crawford agreed. American steel production in 1944 reached approximately 90 million tons. Germany produced about 20 million tons that same year. The numbers kept getting worse. Every station, every piece of equipment, every statistic pointed to the same conclusion. Germany hadn't just been outproduced. Germany had been fighting with industrial technology a generation behind American capability. Heinrich watched Hoffmann's face as the older engineer absorbed the implications. Hoffmann had spent 40 years in German manufacturing. He'd believed in German engineering supremacy. He'd trained young engineers like Heinrich in the certainty that German precision and craftsmanship were unmatched. And he was realizing it had all been a comfortable delusion. Crawford moved them to the 4th station. An electrical control panel, surprisingly complex, with dozens of switches and indicator lights. This is an automated quality control system. Each component produced by our machines passes through inspection stations with go/no-go gauges. If a part fails tolerance, this light activates and the defective part is automatically rejected before it enters the assembly process. Weber leaned closer. Automated quality control? We inspect manually by skilled inspectors. Crawford nodded. Yes. Which means your inspection speed is limited by human capability and subject to human error. This system checks 200 parts per minute with 0 errors. It never gets tired, never gets distracted, never has a bad day. And it's not just speed. When this system detects a defective part, it also records data. How many defects per hour, what type of defect, which machine produced it. We use that data to adjust the production machines before they produce more defective parts. Heinrich understood what Crawford was describing. Feedback loops. Real-time quality adjustment. The Americans weren't just producing more. They were producing more with consistent quality and continuously improving the process based on statistical data. German factories relied on inspectors catching problems after they occurred. American factories prevented problems from occurring in the first place. Dieter asked, and the workers operating these machines? What education do they require? Crawford smiled. High school education, typically. 2 to 4 weeks of specific training for their station. The machines are designed to be operated by normal people, not specialists. Germany had spent the war desperately trying to train enough skilled machinists and engineers while losing them to military service and combat deaths. America had designed a system that didn't need skilled workers. Any reasonably intelligent person could operate the machines after brief training. The implications for post-war competition were staggering. Germany would need decades to rebuild its pool of skilled craftsmen. America would just turn on the machines and start producing again. The 5th station displayed something that made Heinrich's chest tighten. Production Planning Board. Crawford explained the system. Every part, every subassembly, every component is tracked. This board, replicated in every major factory, shows the entire production schedule. When parts are needed, when they're produced, when they're shipped, where they go. Everything coordinated. The Americans had turned warfare into a supply chain management problem. And they'd solved it with the same systematic efficiency they applied to everything else. Hoffmann spoke quietly, almost to himself. We never had a chance, did we? Crawford's expression softened slightly. No, sir. You didn't. American industrial capacity in 1939 exceeded the combined capacity of Germany, Japan, and Italy. By 1944, we were outproducing the entire Axis by a factor of 3 to 1 in most categories. We built 300,000 aircraft during the war. Germany built about 120,000. We built 88,000 tanks. Germany built 49,000. We built 6,500 naval vessels. Germany built fewer than 1,500. Heinrich felt the numbers crushing down like physical weight. Every statistic, every comparison, every piece of equipment pointed to the same conclusion. Germany hadn't lost because of military mistakes or strategic errors. Germany had lost because they challenged an industrial colossus whose productive capacity exceeded their own by such a margin that defeat was mathematically inevitable. The sixth station contained documentation. Technical manuals, production schedules, training materials. Crawford picked up a thick binder. This is the complete assembly manual for the Pratt & Whitney R2800 double WASP engine. 2,000 horsepower, 18 cylinders, one of the most complex engines we produce. This manual contains every specification, every procedure, every tolerance. An engineering graduate with no prior experience can use this manual to assemble the engine in approximately 40 hours. Weber took the manual, flipping through pages of detailed diagrams, step-by-step instructions, torque specifications, quality check procedures. Everything was documented. Everything was standardized. Nothing was left to individual interpretation or craft knowledge. "This is how you do it," Weber said slowly. "This is how you train workers in 2 weeks. You've documented everything. All the knowledge that would normally take years to learn through apprenticeship, you've captured it in manuals." Crawford nodded. Institutional knowledge. We don't rely on master craftsmen passing down skills. We systematize the knowledge, document it, make it reproducible. Any competent person can follow these instructions and produce a quality engine. Heinrich thought about his own training. Years at technical university, followed by years of apprenticeship with senior engineers. Learning by doing, by watching, by absorbing the accumulated wisdom of men who'd spent lifetimes in manufacturing. The Americans had made all that obsolete. They'd captured the knowledge in books and trained new workers in weeks. Dieter asked, "And these manuals? How many exist? 1 per factory?" Crawford laughed. 1 per worker. Every man on the assembly line has access to the complete documentation for his station. If he forgets a procedure, he checks the manual. If there's a question about tolerance, he checks the manual. We've printed millions of copies of various technical manuals during the war. The Germans were silent again. Millions of copies. Germany carefully guarded technical knowledge as proprietary secrets. America distributed it freely to factory workers. The 7th station displayed something that completed the picture of American industrial philosophy. A training mock-up. A section of aircraft fuselage with all the components labeled, color-coded, with step-by-step assembly instructions displayed on boards. Crawford gestured to it. New workers train on this mock-up. They practice their station tasks until they can complete them in the required time with 0 errors. Only then do they move to the actual production line. Training is standardized, measurable, reproducible. One of the German engineers, a man named Ernst who'd remained quiet until now, spoke up. "Major Crawford, a question. How long did it take America to develop this system?" Crawford considered. "Henry Ford pioneered the moving assembly line in 1913. We've been refining mass production techniques for over 30 years. The system you're seeing represents 3 decades of continuous improvement."
Ernst nodded slowly.
"And Germany? We've been building aircraft since the 1930s. Only 15 years. Still using craftsman methods because that's what we knew." Crawford's expression was neutral. Different industrial philosophies. Germany valued quality and craftsmanship. America valued quantity and efficiency. In peacetime, either approach works. In total war, only one approach can sustain the production levels required. Heinrich understood what Crawford wasn't saying directly. German engineering excellence had built magnificent machines. The Tiger tank, the Me-262 jet fighter. Weapons that were individually superior to anything the Allies produced. But superior individual weapons didn't matter when the enemy could produce 10 adequate weapons for every 1 superior weapon you built. The 8th station featured raw material samples. Steel ingots, aluminum billets, copper wire, rubber compounds. Each labeled with origin, composition, and production volume data. Crawford picked up an aluminum billet. American aluminum production in 1943 reached 920,000 tons. Germany produced approximately 250,000 tons. We had access to bauxite from South America, cheap electricity from hydroelectric dams, and no bombing disrupting production. Weber examined the aluminum. The quality is excellent. This is aircraft-grade material. Crawford nodded. Everything we produce is aircraft-grade or better. We don't make different quality levels. We make one quality, high quality, and we make it in massive quantities. It's more efficient to produce one standard than to maintain multiple production lines for different grades. Another efficiency that German engineers hadn't considered. Germany produced different quality materials for different applications. Premium steel for tanks, standard steel for trucks, low-grade steel for non-critical uses. It meant maintaining multiple production processes, multiple supply chains, multiple quality control systems. America standardized everything and produced only high-quality material. Simpler, faster, and ultimately cheaper despite the higher quality. Hoffman asked, and the cost? Surely this level of quality is expensive? Crawford pulled out another document. A Sherman tank cost approximately $45,000 to produce in 1944. The price decreased each year as production efficiency improved. In 1942, the same tank cost $60,000. Economies of scale. The more you produce, the cheaper each unit becomes. Heinrich knew German production costs were moving in the opposite direction. As skilled workers were drafted, as materials became scarce, as Allied bombing disrupted supply chains, German production costs were increasing. A Panther tank that cost 117,000 Reichsmarks in 1943 cost nearly 150,000 Reichsmarks by 1945, and quality was declining even as cost increased. The ninth station displayed something unexpected. Women's work clothing. Overalls, work gloves, safety equipment, all sized for female workers. Crawford explained. Approximately 40% of American war production workers are women. When our men enlisted, women filled the factory positions. Rosie the riveter. We trained them, equipped them, paid them wages comparable to male workers. They kept production running while our men fought. Dieter looked shocked. Women operating these complex machines? Crawford's expression hardened. Women are as capable as men of following procedures and operating equipment. We needed workers, they needed income, the system worked. Some of our best quality control inspectors are women. Their attention to detail exceeds many male workers. Germany had mobilized women into some factory work late in the war, but nothing like the scale Crawford described. German ideology had emphasized women's roles as mothers and homemakers. America had utilized half its adult population as industrial workers while Germany left that capacity largely untapped. Another advantage. Another multiplication of productive capacity. The 10th station contained something that made Heinrich's engineering heart sink. A display of American machine tools. Not just one or two examples, but dozens of different types. Lathes, mills, grinders, boring machines, stamping presses, each with specifications showing production rates, precision tolerances, and maintenance requirements. Crawford gestured across the display. These are catalog items. Any American factory can order these machines from manufacturers. Standard specifications, standard interfaces, standard tooling. You can mix equipment from different manufacturers and they work together because everything follows standard measurements and fittings. Weber understood the significance immediately. Standardization. You've standardized everything across your entire industrial base. Crawford confirmed. Yes. A half-inch bolt is a half-inch bolt whether it's made in Detroit or California. A machine tool from Cincinnati uses the same electrical specifications as one from Massachusetts. A mechanic trained on Ford equipment can work on Chrysler equipment because the basic principles are identical. Germany's industrial base was fragmented. Each company had proprietary systems. A mechanic trained on Daimler-Benz engines couldn't necessarily work on BMW engines without retraining. Equipment from different manufacturers often used different measurements, different voltage standards, different threading specifications. It meant duplicate training, duplicate spare parts inventories, duplicate everything. Inefficient in peacetime, fatal in war. The 11th station featured photographs. Aerial views of American factories. Crawford pointed to one image showing a massive complex. The Willow Run plant, 1 mile long, quarter-mile wide. At peak production, one B-24 Liberator bomber rolled off the assembly line every 63 minutes. 1 bomber per hour. Heinrich stared at the photograph. The building was larger than some German towns. The parking lots visible in the photo held thousands of vehicles. The number of workers required must have been staggering. How many employees? Heinrich asked. Crawford checked his notes. Approximately 42,000 workers at peak. Running 3 shifts, 24 hours per day. Heinrich did the mathematics. 42,000 workers producing 650 bombers per month. That was roughly 1 bomber per 65 workers per month. In Germany, producing a single heavy bomber required perhaps 100 workers and took nearly 2 months. American efficiency was 3 to 4 times higher. Ernst spoke quietly. When did this facility begin production? Crawford smiled grimly. Ground was broken in 1941. First bomber rolled out in September 1942. 16 months from empty field to full production. Less than 2 years. Heinrich thought about German factory construction. Planning permissions, resource allocation, construction in the face of Allied bombing, equipment installation, worker training. A major new facility might take 3 or 4 years to reach full production. America had built the world's largest aircraft factory and reached peak output in 16 months. Hoffman asked the question they were all thinking. How many facilities like this does America have? Crawford gestured to a wall map covered with pins. Each pin represents a major war production facility. Aircraft, engines, vehicles, weapons, ships, electronics. The map was covered with pins. Hundreds of them clustered around major cities, spread across an entire continent. Detroit, Chicago, Los Angeles, New York, Seattle, dozens of other cities. Germany's war production was concentrated in the Ruhr Valley, in Berlin, in a few other industrial centers. Concentrated meant efficient in terms of supply chains, but it also meant vulnerable to bombing. America's production was dispersed across a continent-sized nation. You couldn't knock it out with strategic bombing because there were too many targets spread over too vast an area. The 12th station displayed something that hurt worst of all. Production statistics printed on large boards. Clear numbers showing exactly how badly Germany had been outmatched. Aircraft production comparison, 1944. United States 96,318. Germany 39,807. Tank production 1944. United States 17,565. Germany 8,328. Artillery pieces 1944. United States 38,000. Germany 23,000. Every category showed the same pattern. America producing 2 to 3 times more than Germany, sometimes more. But the raw numbers didn't tell the complete story. Crawford pointed to a second board. Now factor in quality and survival rates. A Sherman tank might be inferior to a Tiger tank in direct combat. But we produced 5 Shermans for every Tiger. And our Shermans were mechanically reliable. They didn't break down. They could be repaired in the field with standard parts. They could be operated by crews with minimal training.
Dieter nodded slowly.
I've read the reports. German tank crews complained that Tigers broke down more often than they encountered enemy tanks. The transmission failures, the engine problems, the complexity. Crawford continued. The Tiger was an engineering marvel. But it required specialized tools, specialized parts, specialized training. It took 3 times as long to produce as a Sherman. And when it broke down, it often had to be abandoned because you couldn't get replacement parts to the front. We lost plenty of Shermans in combat. But we could replace them faster than you could destroy them. That was the mathematics of industrial warfare that German leadership had never grasped. Individual technical superiority meant nothing if you couldn't produce enough units, maintain them in the field, and replace losses faster than the enemy could inflict them. Heinrich thought about the Me-262 jet fighter. Revolutionary technology. Far superior to any Allied aircraft. Germany had produced fewer than 1,500 of them, many of which never flew combat missions due to fuel shortages, part shortages, or lack of trained pilots. Revolutionary technology was useless if you couldn't deploy it in decisive numbers. The 13th station showed shipping and logistics equipment. Crates, containers, loading equipment, trucks. Crawford explained, "This is how we move everything. Standardized containers, standardized trucks, standardized loading procedures." A Sherman tank can be loaded onto a cargo ship in Detroit, shipped to England, offloaded, and driven into combat within 6 weeks of leaving the factory. Every step is systematized. Ernst asked, "And the shipping capacity?" Crawford pulled out yet another document filled with statistics. American merchant marine tonnage in 1944 exceeded 20 million gross tons. We built approximately 2,700 Liberty ships during the war. Each Liberty ship carries 10,000 tons of cargo. The Germans exchanged glances. They'd known American industrial production was high, but they hadn't understood the logistics infrastructure supporting it. Germany could produce weapons, but getting them to the front was increasingly difficult. Allied bombing disrupted rail networks. Fuel shortages limited trucking. The Eastern territories were so vast that logistics consumed enormous resources. America had built a logistics system that could deliver weapons from factories in Detroit to battlefields in Europe or the Pacific with systematic efficiency. Crawford continued, "A Liberty ship took approximately 70 days to build in 1942. By 1943, we'd reduced that to 42 days. By 1944, some ships were completed in less than 30 days. We were building ships faster than Germany could sink them with submarines. That's when we knew we'd won the Battle of the Atlantic. Building cargo ships in 30 days. Heinrich tried to imagine building an ocean-going vessel in 1 month. It was impossible, except America had done it repeatedly thousands of times." Weber spoke, his voice hollow. "We never had a chance. From the beginning. From 1939. Even if we'd won every battle, even if our tactics had been perfect, even if our generals had made no mistakes. We couldn't win because you could simply outproduce us." Crawford's expression was neutral, but there was no disagreement in his silence. The truth hung in the air between them. Germany had challenged an industrial superpower whose productive capacity exceeded German capability by such a margin that military excellence couldn't compensate. The 14th station displayed something more subtle but perhaps more significant. Educational materials. Technical journals, engineering textbooks, university catalogs. Crawford picked up a journal. American engineering education produces approximately 50,000 graduate engineers per year. We have over 200 universities with engineering programs. Technical knowledge is widely distributed, constantly updated, shared across industries. Heinrich had been educated at one of Germany's finest technical universities, a privilege reserved for a small elite. The idea that America was producing 50,000 engineers annually was staggering. That level of technical education distributed across an entire society meant continuous innovation, constant improvement, and a pool of educated workers far exceeding what Germany could mobilize. Hoffman examined one of the textbooks, Massachusetts Institute of Technology, Mechanical Engineering Curriculum. The book was thick, comprehensive, covering everything from material science to production management. And this is standard education, available to any student who qualifies? Crawford nodded. Merit-based admission. If you have the ability and the grades, you can attend. No aristocratic privilege required. Financial aid available for students who can't afford tuition. We believe in developing talent wherever we find it. Germany's education system, for all its excellence, was still partially structured around class and privilege. University education was difficult to access for working-class students. Talent was being lost because the system couldn't identify and develop it efficiently. America was mining its entire population for engineering talent.
Dieter spoke quietly.
The industrial capacity, the production systems, the logistics, the standardization, the educational infrastructure. It's not just that you won the war. You were always going to win. The moment war was declared, the outcome was inevitable. It just took 6 years for the mathematics to play out. Crawford didn't argue. Instead, he gestured to the final station. The 15th display featured a large chart showing comparative gross domestic product, industrial output, and resource availability. The numbers were stark. United States GDP 1940, $1.03 trillion. German GDP 1940, $384 billion. United States industrial production 1940, index value 100. By 1945, index value 196, nearly doubled during the war. German industrial production 1940, index value 100. By 1945, index value 88, declined due to bombing and resource shortages. United States oil production 1943, 1.5 billion barrels. German oil production 1943, 34 million barrels, including synthetic fuel. 44 times difference. Oil was the blood of mechanized warfare. Tanks, aircraft, trucks, ships all required fuel. America was swimming in oil. Germany was desperately trying to synthesize enough fuel to keep fighting. Crawford let the numbers speak for themselves. Then he added one final observation. Gentlemen, I want you to understand something. This exhibition isn't meant to humiliate you. It's meant to educate you. Because the world is going to rebuild now. And you need to understand why you lost so you can understand how to compete in peace. Heinrich appreciated the honesty, even though it hurt. Crawford was right. Understanding the scope of American industrial superiority wasn't just historical analysis. It was essential knowledge for anyone hoping to rebuild Germany's economy after the war. Ernst spoke up, his voice thoughtful. Major Crawford, you said this is standard equipment. Not experimental, not secret. Does that mean this represents American capability from the beginning of the war? Crawford considered the question. Much of this technology existed in 1939, yes. Some refinements were made during the war, but the fundamental systems were already in place. We scaled up existing capacity rather than inventing new methods. The implications settled over the German engineers like a weight. America hadn't developed revolutionary new production methods during the war. They'd simply expanded what they already knew how to do. Germany had been decades behind from the start. Weber asked, and now? After the war? What happens to this industrial capacity? Crawford gestured broadly. Some factories will convert back to civilian production. Cars instead of tanks. Airliners instead of bombers. Washing machines instead of artillery shells. But the capacity remains. The expertise remains. The systems remain. Hoffman understood immediately. America would enter the post-war world with industrial capacity far exceeding any other nation. While Europe rebuilt from ruins, America would be producing civilian goods with the same efficiency they'd produced weapons. The economic implications were as decisive as the military ones had been. Heinrich asked the question that had been forming since the tour began. Major Crawford, was there any point during the war when Germany could have won? Any decision, any strategy, any weapon that could have changed the outcome? Crawford thought for a long moment before answering. Honestly, no. Not after December 1941 when America entered the war. Before that, perhaps Germany could have negotiated a settlement with Britain. But once American industrial capacity was mobilized against you, mathematics took over. You could have had better generals, better tactics, better weapons. But you couldn't overcome a 3-to-1 production disadvantage. The German engineers stood silent, absorbing this final truth. All the sacrifice, all the effort, all the brilliant engineering had been futile. Not because German technology was inferior, but because German industry couldn't sustain war against an opponent who could outproduce them by such massive margins. Dieter spoke quietly. Our leaders must have known. The economics were public information before the war. GDP figures, industrial output, steel production, oil reserves. Anyone could look up these numbers. Crawford nodded. Many German military leaders did understand the numbers. They argued against war with America, but they were overruled by political leadership who believed willpower and racial superiority could overcome material disadvantages. Heinrich thought about the Nazi propaganda he'd heard throughout the war. The emphasis on German racial superiority, on will and courage, on the inevitability of victory. Mathematical reality had been subordinated to ideological fantasy. The engineers had known the numbers didn't work, but saying so publicly would have been defeatism, punishable by death. So they'd kept building weapons, improving designs, working harder, knowing in their hearts that effort couldn't overcome the fundamental disparity in industrial capacity. Ernst asked, "What happens to us now? German engineers in an occupied country?" Crawford's expression was neutral. "That depends. Some of you will be investigated for war crimes participation. Most won't be charged. Germany will need engineers to rebuild. Some of you may be offered opportunities to work for the Allies, sharing your technical knowledge. The jet engine technology, the rocket technology, that's valuable. But understand this. The world you're entering is one where America sets the industrial standards, where American methods define manufacturing best practices, where American efficiency is the benchmark everyone else tries to match." The tour concluded, but Crawford invited the engineers to examine any equipment more closely. Heinrich found himself drawn back to the Cincinnati milling machine, the massive automated tool that could produce 200 engine blocks per month. He ran his hands over the precision ground surfaces, examined the automated feed mechanisms, studied the tool changers. It was beautiful in its own way, not the aesthetic beauty of a handcrafted masterpiece, but the beauty of systematic efficiency. Every element designed for its function. Nothing wasted, nothing ornamental, pure purpose. Weber joined him. "We've been approaching manufacturing wrong for decades."
Heinrich nodded.
"We thought craftsmanship was the goal. They understood that reproducibility was the goal. We celebrated the master machinist who could produce a perfect part. They celebrated the system that could produce 1,000,000 identical parts." Hoffman approached, looking older than he had 3 hours earlier. "I've spent 40 years in German manufacturing. I trained under men who learned their craft in the 1890s. Everything I know, everything I've taught, it's all obsolete." Heinrich wanted to offer comfort, but couldn't find the words. It was true. The entire German approach to manufacturing, refined over generations, had been made obsolete by American systematization. Dieter was examining the production planning board, the complex system for tracking parts and scheduling. "This is what we're missing. Not just the machines, the management systems, the documentation, the training systems, the standardization. It's a complete industrial philosophy." Crawford, overhearing, approached. "That's exactly right. The machines are just tools. The real American advantage is systematic thinking. We approach manufacturing as an engineering problem to be solved, not a craft to be perfected. We optimize for efficiency, for reproducibility, for scale." Ernst spoke up. "Can we learn this? Can Germany adopt these methods?" Crawford considered. "The methods, yes. The scale, not for a long time. America has been building this industrial infrastructure for 50 years. You're starting from rubble. It will take decades to catch up if you ever do." Heinrich thought about post-war Germany. Cities destroyed, factories bombed, infrastructure shattered, raw materials scarce, the educated workforce depleted by war casualties. Starting from that position, competing with an America whose industrial plant had expanded during the war rather than being destroyed, seemed impossible. But what choice did they have? Weber asked quietly, "Will you help us? Will America help rebuild German industry?" Crawford's expression was carefully neutral. "That's above my pay grade. Political decisions. But I can tell you this, America needs trading partners. We need markets for our goods. A prosperous Europe is in American interests. So yes, there will likely be assistance. But understand, any assistance will come with conditions. You'll be expected to adopt democratic governance, to reject militarism, to integrate into an American-led economic order." The terms were clear. Germany could rebuild, but only as a junior partner in an American-dominated system. The alternative was remaining in ruins. Heinrich understood the mathematics of that choice too. Hoffman asked Major Crawford one final question. "When did you know you'd won? At what point in the war did America realize victory was inevitable?" Crawford smiled slightly. In my case, late 1943, I was working at Ford Willow Run. We hit our production targets, 650 bombers per month. I did the math, calculated how many bombers we were producing versus how many Germany could shoot down. Realized we could sustain losses indefinitely while Germany couldn't. That's when I knew. It was just a matter of time. For the German engineers, there had been no such moment of clarity. They'd been told Germany was winning until nearly the end. Even as Soviet forces approached Berlin, propaganda insisted that wonder weapons would turn the tide. Now, standing in a captured factory being lectured on American industrial superiority, the scope of the deception was clear. Heinrich left the exhibition hall and walked outside. The May afternoon was warm, but he felt cold. Other German engineers stood in small groups, smoking cigarettes, speaking in low voices. Their faces showed the same hollow expression Heinrich felt inside.
Ernst Approachet.
Dr. Müller, what will you do now? Heinrich considered the question. Find work, I suppose. Help rebuild. What else can we do? But what he was thinking was more fundamental. Everything he'd believed about German technical superiority was false. Everything he'd been taught about efficient manufacturing was outdated. Everything he'd worked toward during the war had been based on flawed assumptions about Germany's competitive position. Weber joined them. I've been thinking about what Crawford said, about how America will help rebuild but only on their terms. We're going to become an economic colony. Heinrich shook his head. Not a colony, a client state. There's a difference. We'll have autonomy, but we'll exist within an American-dominated economic system, using American methods, adopting American standards, competing on American terms. Dieter walked over, overhearing. Is that bad? Honestly, is American economic domination worse than what we had? At least their system produces prosperity. Our system produced war and destruction. The question hung in the air. Germany had sought autarky, economic self-sufficiency, separation from the global market. It had led to resource shortages, inefficiency, and ultimately military aggression to secure what the economy couldn't produce domestically. America offered integration into a system of trade, standardization, and mutual dependence. Loss of sovereignty in exchange for access to markets and resources. Hoffman, standing nearby, spoke quietly. I remember the 1920s, after the First War. The hyperinflation, the unemployment, the poverty. People were desperate. When the Nazis promised to make Germany great again, to restore our power, to reject the global economic order that had humiliated us, it sounded appealing. We thought autarky and military strength would make us independent. Instead, it made us vulnerable.
Heinrich nodded.
We isolated ourselves and fell behind industrially. While we were pursuing racial ideology and military expansion, America was refining mass production and building economic scale. We chose power. They chose efficiency. Guess which one wins in the long run? A young German engineer Heinrich didn't know approached their group. I've been offered a position. American technical intelligence wants engineers who understand German rocket technology. They're taking us to America. Good pay, research facilities, a chance to work on advanced projects. Are you going? Heinrich asked. The young man nodded. What's left for me here? My city is rubble. My family is dead. My university is destroyed. At least in America I can do engineering again. He walked away, leaving the older men standing in silence. The brain drain was beginning already. Germany's brightest technical minds being recruited by the victors, taking their knowledge to America, further widening the gap in capability. That evening, Heinrich sat in the small apartment he'd been assigned by the occupation authorities. He'd retrieved his personal notebooks from storage, journals where he'd recorded technical observations and calculations throughout his career. He opened one from 1938, reading his own handwriting from 7 years earlier. Notes on engine efficiency, calculations on production methods, optimistic projections about German industrial development. The notes of a man who believed Germany was at the forefront of technical progress. He'd been wrong, not slightly wrong, fundamentally completely wrong. The evidence had been available all along. but he'd chosen not to see it. American industrial output figures were public information. Any engineer could have looked up the statistics, done the mathematics, and realized Germany couldn't compete. But acknowledging that reality would have meant questioning the entire Nazi narrative about German superiority. Easier to believe the propaganda. Safer to assume the numbers were exaggerated. More comfortable to think that German craftsmanship would somehow overcome American mass production. Heinrich thought about Dieter's question. Was American economic domination worse than what Germany had created? The honest answer was no. The Nazi regime had promised strength through isolation, purity through exclusion, victory through will. It had delivered destruction, poverty, and defeat. America offered prosperity through integration, growth through trade, stability through interdependence. Less glorious, perhaps, but functional. Weber knocked and entered. Heinrich had left the door unlocked. "You're brooding," Weber observed. Heinrich gestured to his old notebooks. "Reading my own certainty from 7 years ago, seeing how wrong I was." "We were all wrong," Weber said, sitting down. "Every engineer who believed German technical superiority would be decisive. Every general who thought tactical brilliance could overcome material disadvantage. Every politician who thought willpower could substitute for industrial capacity. We were all wrong."
Heinrich nodded.
"The question is, what do we do now?" Weber pulled out a letter. "I've been offered a position with the Americans too. Technical advisor. They want help understanding German jet engine designs. Good salary, housing, research budget. Are you accepting?" "I don't know. Part of me wants to say no. National pride. Refusing to work for the occupiers. But pragmatically, what's the alternative? Sit in ruins and starve while clinging to wounded pride?" Heinrich understood the dilemma. He'd face similar offers soon. German engineers with specialized knowledge were valuable. The Americans would recruit them, the British would recruit them, the Soviets would recruit them. Germany's technical expertise was becoming just another resource to be exploited by the victors. "Hoffman has already decided," Weber continued. "He's staying. Says he's too old to start over, too tired to work for foreigners. He'll find some position in occupation administration, help coordinate reconstruction. Live out his remaining years in the country he was born in." Heinrich respected that choice, even if it meant accepting a diminished future. There was dignity in remaining, in rebuilding, even if it meant living in an American-dominated economic order. "Dieter is going to America," Weber added. "He told me this afternoon. Says there's nothing left for him here. His family is dead, his city is destroyed. At least in America he can practice engineering without occupiers watching over his shoulder." "The irony," Heinrich said quietly, "is that Dieter will probably be freer in America than he ever was here. Free to research what interests him, free to speak his mind, free to pursue technical excellence without political interference." Weber laughed bitterly. "Yes, the democratic capitalists offer more freedom to engineers than the nationalist socialists ever did. Who would have predicted that?" They sat in silence for a moment. Then Weber continued. "Ernst is staying too. He's got family in the countryside, a wife and children who survived. He'll find work in reconstruction, probably civil engineering. Rebuilding roads, bridges, factories. Germany will need engineers for that." Heinrich thought about the younger man's choice. Practical, family-focused, reasonable. Germany would indeed need enormous engineering effort to rebuild infrastructure. Perhaps there was dignity in that work, in helping resurrect a destroyed nation. "What about you?" Weber asked. "What will Heinrich Müller do?" Heinrich looked at his notebooks again. All that accumulated knowledge, all those years of experience, all that training in outdated methods. "I don't know," he admitted. "Part of me wants to stay, to help rebuild German industry using what I've learned. To apply American methods to German reconstruction. To ensure we never fall this far behind again." "And the other part?" "The other part wants to accept whatever offer comes from the Americans or British. To work in a functioning laboratory again with adequate resources without interference. To practice engineering rather than politics. To just build things without ideology corrupting every decision." Weber nodded. Most of us are facing that choice. Loyalty to a defeated nation versus pragmatic self-interest. Pride versus prosperity. The old ways versus the new reality. Heinrich stood and walked to the window. Outside, Friedrichshafen was a landscape of ruins. Bomb-damaged buildings, rubble-filled streets, displaced people living in temporary shelters. This was what nationalist ideology and military aggression had delivered. Destruction and poverty. America, untouched by bombing, its cities intact, its factories humming, represented the alternative. Not perfect, but functional. Not glorious, but prosperous. Not racially pure, but productive. I think Heinrich said slowly that we owe Germany honesty. We owe the next generation the truth about why we lost. Not the comfortable lies about betrayal and conspiracy. The hard truth about industrial capacity and systematic efficiency. Weber joined him at the window. Will anyone listen? Or will they prefer comfortable myths? Heinrich shrugged. Some will listen. The engineers will listen because we understand mathematics. The businessmen will listen because they understand economics. The generals will listen because they understand logistics. The politicians might not listen, but then again, the politicians led us into this disaster. Maybe we shouldn't trust politicians anymore. Weber smiled slightly. Dangerous thinking. Democracy requires trusting politicians. Heinrich shook his head. Democracy requires holding politicians accountable. There's a difference. We trusted ours too much, questioned too little. Americans seem to argue with their politicians constantly. Messy, but maybe healthier than blind obedience. They stood together watching the sunset over a ruined city. Two engineers contemplating a future neither had imagined 5 years earlier. The war was over. Germany had lost. The old certainties were dead. What came next was unclear, but one thing was certain. It would be built on American terms, using American methods, within an American-dominated economic order. 6 months later, Heinrich stood in the same exhibition hall where Crawford had delivered his lesson in American industrial superiority. It had been converted into a training center for German engineers learning American manufacturing methods. Heinrich was one of the instructors. He'd chosen to stay, not out of nationalism but out of pragmatism. Germany needed engineers who understood both the old methods and the new reality, who could bridge the gap between German technical tradition and American systematic efficiency, who could translate American industrial philosophy into terms German engineers could understand and apply. His first class consisted of 20 young engineers, most recently returned from POW camps, all eager to learn the methods that had defeated them. Heinrich began with the same tour Crawford had given him, showing the same equipment, citing the same statistics. But he added context Crawford hadn't provided. The Americans won, Heinrich explained, because they understood something we didn't. Manufacturing is not about craftsmanship. It's about systems. They systematized everything. Design, production, training, quality control, logistics. They documented everything. They standardized everything. And in doing so, they created an industrial system that could operate at scale we never imagined possible. One young engineer raised his hand. But German engineering quality is superior. Everyone knows this. Heinrich shook his head. Was superior in individual products. But what matters more in modern manufacturing? 1 perfect product or 1 million adequate products? The young man looked uncomfortable. He'd been raised on propaganda about German excellence. Confronting the reality that excellence didn't matter if you couldn't produce at scale was difficult. Heinrich continued. I spent 15 years believing German methods were the best. I was wrong. Not because our methods were bad, but because they were designed for a different era. We optimized for craftsmanship. America optimized for efficiency. In peacetime, either approach works. In total war, only efficiency wins. He walked them through the same stations Crawford had shown, explaining each system, each method, each philosophy. But he also taught them why these methods worked. The mathematics of mass production, the economics of standardization, the psychology of assembly line work. By the end of the day, the young engineers understood what Heinrich had learned 6 months earlier. They'd been defeated not by better soldiers or better generals, but by better systems. Not by superior individual technology, but by superior industrial organization. As the class ended, several students approached with questions. Some were technical, others were more philosophical. Do we just copy American methods? One asked. Or do we develop our own approach? Heinrich considered the question carefully. We learn from American methods. We adopt what works. But we also apply German engineering rigor to improving those methods. America showed us the path. But that doesn't mean we can't walk it better once we understand where it leads. Another student asked, will Germany ever match American industrial capacity? Heinrich was honest. Probably not. America has advantages we can't replicate. Continental size, vast resources, large population, no war damage. But we don't need to match them. We need to be efficient enough to prosper, productive enough to rebuild, systematic enough to compete. That's achievable. He thought about Crawford's final words during that first tour. This exhibition isn't meant to humiliate you. It's meant to educate you. The lesson had been learned. Germany had been defeated by industrial mathematics, by systematic efficiency, by American manufacturing philosophy that valued reproducibility over craftsmanship, standardization over customization, scale over excellence. The question now was whether Germany could learn from that defeat, whether they could adopt new methods while maintaining technical rigor, whether they could compete in an American-dominated economic order. Heinrich believed they could, not by rejecting American methods, but by mastering them and improving them. The war was over. The education had begun.